Okay, good day, everyone. Today we'll be discussing IP addressing, and then we'll be looking at IP addressing from two distinguished types. The first one is IPv4, and the second one is IPv6. The IPv4 is 32 bit length, and then the IPv6 is 128 bit length. But for today, we'll actually concentrate our explanation on IPv4, which is the Internet Protocol version 4. So I want you to follow and let me know if you have issues at the end of the day. I promise you everything here will be resolved. IPv4 is made up of 5 classes. Class A, Class B, Class C, Class D, and then Class E. For Class A is from the range of 0 to 127. Your Class B is any number from 128 to 191. Your Class C is from 191 to 223. And your Class D is 224 to 239. And then your Class E is from 240 to 255. Now, these are the 5 classes we have under IPv4. Meaning that if any IP address starts from 1 and end up with 127, automatically you will know it's a Class A. And if you get any IP address that starts from 128 to 191, you know it's a Class what? B. And then same to C, D, and E. Now, Class D, you need to note this for the record. Class D is actually for multicast, And then Class E is reserved for experimental purposes. So for you to assign IP addresses on your internet network for NAT purposes and all of that, you're actually going to be making use of A, B, and C. So we'll go on to look at how you use the Class A, B, and C. Remember that your A is 0 to 127, your B is 128 to 191, and then your C is from 192 to 223. So you need to note that very importantly. Now, IPv4 is actually made up of 4 groups, or what we call 4 strings, or you can as well say it is of 4 octets. So you're going to have numbers like 11.12.13.4. Now, if you look at this set of numbers, they are separated with a dot, okay? And these are decimal numbers. But in IPv4, well, we have to convert this decimal to binary and then binary back to decimal. So it's always the case here. But then you need to note that it must be in binary, and if it's binary, it's going to be in octets. In other words, 4 bits of that's strings of zeros and ones that must be of 8 bits. Same thing in the next group, or what was string, the 3rd string, and then the 4th string. So we're going to look at how to arrange these bits of zeros and ones by converting these decimal numbers. So let me look for a very easy one to start with, so that you can be able to follow without much challenges. And most of you guys who actually have been handling the network will see that maybe 192.168.10.1, for instance. Now, this is actually an IP address. Remember, it's a 192.168.10.1. Now, this dot is used to separate one decimal value from another decimal value, just for the ease of computation. But your computer system does not identify these dots. Right, so now let's see something here. I'm going to ask this. What class of IP address is this? And then if you look at it critically, if you recall, we said from 0 to 127 is A, and then we said from 128 to 191 is B, and then we say from 192 to 223 is C. So automatically, because the first number actually is within the range of 192 to 223, we now say this is the class what? A class C. It's a class C IP version 4 address. And that's how we identify this number. So I'm going to write out some set of IP addresses and see if we can follow to be able to identify their classes. For instance, we have an IP address of 129.10.10.1. We have 191.4.4.5. We have 92.5.5.5. We have 172.8.8.8. Now, looking at this set of IP addresses, the question now comes, what classes do they belong to? Now, if you look at the first one, which is 129.10.10.10.1, you agree with me that because it falls within 128, remember 0 to 127, 128 to 191, 192 to 223. Told you that you have to ignore D and E for now because they are reserved for some purposes. So we actually are going to concentrate on this set of IPv4 addresses. So here, 129.10.10.1, I would say is a class B because it falls within the range of 128 to 191. And then I'll also say 191.4.4.5 also falls within this range. So it's also a class what? B. So this is B, this is B. And then looking at the third one, which is 92.5.5.5.5, I would say this number falls within the first one range here, which is A. So I would say this is a class A. And then looking at the fourth one, which is 172.8.8.8, I would say this actually falls within the second range, which is class B, still class B. So if you agree with me that we now have the different classes represented here. So this is how we get to know which class of IP address we're dealing with. Okay, so if you're able to understand this, automatically, if you see an IP address at every point in time, you'll be able to tell if it's a class A, a class B, a class C, D, and a class E IPv4 address. Now we are going to further to be able to distinguish what we say, what we call private and public. Private and public. IPv4 actually is further divided into what we call private and public addresses. The private IP address is the one you actually use in your organization for configuring your intranet network. In some cases, you can also use it for extranet. And then the public IP address is the one that is assigned by IANA, which is the Internet Assigned Number Authority. And so now we need to also see how we can be able to distinguish these numbers and tell which one falls under private and then which one falls under public. So the private is used within the organization, and then the public is actually used to be able to connect remotely, connect to other networks, and be on the internet for any other purposes, for sharing resources, as the case may be. So we are going to see that and then be able to distinguish between the two. So I will start. The same body, IANA, gave us the opportunity to know the private IP address, and then we can now be able to figure out which happens to be the public IP address. So for the private IP address, for private, it gave us For a class A, we said we should use 10.0.0.0 to the range of 10.255.255.255. For your information, for IPv4, the maximum number you can get is 255. There's no 256. And they said, okay, this is for private IP address, class A. That means any numbers within this range is considered private class A. And then they went further to give us 172.16.0.0 to 172.31.255.255 as class B private IP address. And then for C, they gave us 192.168.0.0 to 192.168.255.255. So, ladies and gentlemen, these are what we call the private IP address. So now we are going to do something here. We'll bring out some IP addresses and try to tie them to either private or public. Remember, you can also recall that prior to this subtopic, we've said that 0 to 127 is A. We also agreed that 128 to 191 is B. We also we're given 192 to 223 as what C. So it means that we are aware that 0 to 127 is A, 128 to 191 is B, 192 to 223 is C. But now here is the private IP address given to you. So you know that 10 is automatically within this range, and that is why they consider it as private A. Same thing to B and C. But now let us now be able to see that if and the particular IP address is given to us, we can be able to tell if it is private or public. So I'm going to give us 198.255.254.1. And I'm giving us another number which says 172.17.30.3. And then you have another number that says 8.8.8.8. And then you have another number that is given as 192.169. I think stop here by proper view. So now, if you're asked to tell whether this IP address is public or private, if you look at the first one, 198.255.254.1, if you take the first decimal value here, which is 198, and then you look at all these numbers given here, the ranges of numbers given here, 198 actually is not here. You can find it in this range, you can find it in B, you can find it in C. So actually, we see we have it as 192. But recall that from 192 to 233 is what? C. So that means this 198 is actually a class C because it falls within this range. But it's going to be a class C public. Why? Because it's not in the range of a class C private. So we're going to say this is class C, but what? Public. So I'm going to use PL as public. Now, the second one here says 172.17.30.3. Of course, 172 is within the range of B, that means a class B, but now let's tell if it's private or public. Looking at what we have here, this is the next decimal value here, which actually falls in the next octet, is 17. 17 is actually within the range as well, because if you look at the second value here, which is 16, they're telling you that you can increase this 16 on the second string to get to 31, but you must not exceed 31 for it to be private. So the very moment you exceed 31 on the second octet or on the second value there, automatically becomes public. So here we have it as 17, so it's within the range. So we're going to say it's class B. Class B what? Private. EV should be private. And then looking at the last one here, which is 8.8.8.8, actually falls within this range. So automatically is the class A. A what? Private. So this is how we get the private IP addresses and then the the public IP address. So I want to believe that now every one of you should be able to tell which one is private and then which one is public. So I'm going to give some further examples to see if that will also help us as well. Eventually, you're giving 223.4.5.5, and then you're giving 172.32.5.5, and then you're also giving 11.5.5.5. Now, I'm going to ask you now, categorize these IP addresses into private, public, and then also let us know the class they belong to. Now, if you look at this critically, for the first one, let's work it together. 223.4.5.5 is actually a class C. Why? Because this 223 falls within the class C range. So it's a class C. So that means you've gotten it to say class C. And then let's look at the range here. It's actually out of the range for for it to be class C private. So it's going to be a class C public, PL. Now, the second one, let me give you the opportunity to work it out yourself before I solve this. So tell me now if it's going to be a private or public, and then which class does it belong to? Okay. So let's do it together. Let's see if you actually got it right or not. Now, for the second one, which is 172.32, 172 is 172 here. Perfect. So it means it is a what? A class B. Right? But then if you look at it here also, the second number here is 32. But then we're told that for it to also maintain private B, it has to be 31. That's from 16, can be 17, can be 18, can be 19 on the second string, but it must not exceed 31. So in this case, that exceeded 31. So it's going to be class B, public. Now, 11.5.5.5. Looking at 11 is within the range of 0 to 127, so it's actually class A. So if you say class A, then you're correct. But then if you look at it, actually it has exceeded 10 in this range. So because it has exceeded 10, it's going to be public, so class A public. So this is how we arrive at public and private IP addresses. And I believe explanation is good enough for us. Now, the next thing here I would like to show us is to let you know that for every IP address, there's usually what we call the subnet mask. So we're going to look at subnet mask. Now, IP addresses is what you use to identify your computers in terms of sharing resources. Every computer that must be able to share resources must have an IP address. And for that system to communicate effectively, those IP addresses must be tied to a subnet mask, because it's from the subnet mask to tell which portion is reserved for the network and then which portion should be assigned to systems like your computers, your printers, your IP camera, and the rest of them. So we're going to look at the subnet mask. For information, subnet mask means sub-network mask. We have it in a different category. We have the class A. Remember, we already have class A prior to now. We're going to see the subnet mask for class A. It's giving us 255.0.0.0. So please note this for future purposes. And then for a class B, class B is given as 255.255.0.0. And then the class C is given as 255.255.255.0. So please note this, that these are what we call default. Default, please note it down. Default subnet mask. Now, if you convert 255 to binary, let's do that together. 255 to binary. It means 2 into 255 is 1, 2, and then you're going to have 1 here with a 7, so remainder 1. 2 into 1 to 7 is 6. This is 3, remainder 1. 2 into 63 is 3. This is 1, remainder 1. 2 into 31 is 15, remainder 1. 2 into 15 is 7, remainder 1. 2 into 7 is what? 3, remainder 1. 2 into 3 is 1, remainder 1. Then you have remainder 1 here. This is 1, 2, 3, 4, 5, 6, 7. So that means if you're going to convert 255 to binary, you're going to have 8 ones. So you see, so you're going to have 8 ones as 255. So please note that. So we're going to actually convert all these things. So you know that the 0.9 is what happens. So here, it means that for a class A, you must convert it to binary. You're going to have it this way. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then this is 0. 0 now is 8 bits of zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It's 8 bits of zeros. So it's all 8 bits of zeros. Then for B, the same thing. You convert this to binary, you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then for C, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then all these are there. So this is what happens here for information. Whenever you have it as 1, it is the network. Whenever you have it as zeros, is the host. So ones represent network, and then zeros represent host. So this is a trick. So if I have a class A network, a default class A network, it means that I have this portion to give me the host. So there's a formula I'm going to give us. If it's network, the formula is 2 to the power of n, defines the network. And if it's a host, it's telling you that 2 to the power of n minus 2, where n is the number of bits. Remember, this bit we're talking about could be zeros or 1. So if it is network, it is 2 to the power of n. If it is host, it's 2 to the power of n minus 2. Now, I'll tell you why we're minusing 2 for the host. The reason why I'm minusing 2 for the host is that it's assumed that in any given network, the first number and the last number, it is not used. You don't use the first number and the last number, because the first number is reserved for the network address, and the last number is reserved for the broadcast address. So you don't tamper with the first and the last number. So now we are going to do some small calculations here, which will help us understand the number of network reserved for default class A and for B and for C. So since you have this formula, let's work out something together. If you are asked this question and said, what is the maximum number of networks that I can be getting for a default class A? You just come with your calculation and say, oh, 2 to the power of n, where n is all bits of 1s, which is 8 here. And when you say 2 to the power of 8 is 256. So you're going to have 256. 256. Yeah, 256 network under default class A. Then what is the host? How many hosts are you going to get? Remember, if you count all these bits of zeros, they are 24. So you're going to have 2 to the power of 24 minus 2. That's a big number. It's about 16 million plus. You can do that and check yourself. So this is what you get for your host. And let me see if you can see that clearly. Good. So that is what you get for your host. 2 to the power of 24 minus 2, which is said to give you 16 million. That's for the host. Now always remember you're going to minus the 2 for me. for the host. And then for B, what do you get for B? You can try that on your own. So I work mine. For B, you can act for the network is 2 to the power of n. So in this case, it's going to be 2 to the power of 16, looking at the number of ones here, which gives about 65,000 plus. 65,000 plus. So it means that you're going to have 65,000 networks from a default class B. Isn't it wonderful? Then for the host, which is 8 here, is 2 to the power of n minus 2. Remember, we're dealing with hosts, we're dealing with zeros. So the number of zeros here also is 16, which is about 65,000 plus hosts. So that's the number of hosts you can get from a default class B. That's what you get. Now, the last one we're going to do here is for C. For C, for class C is n, which is network, is 2 to the power of n. In this case, it's 2 to the power of 24. So it's telling you that you're going to have 16 million plus networks. Okay. And then for C, and for the host is going to be 2 to the power of what? 8 minus 2. So 2 to the power of 8 is 256 minus 2 is 254. 254. So that means that in a typical class C network, you get 254 usable IP addresses. Usable IP addresses. Okay, that's fantastic. So, ladies and gentlemen, you also agree with me at this note that for class A, you have 8 bits of ones. That means that it's going to be what we call /8. So usually, as we go further, you begin to see me using slash and all of that. So I need to capture that here before we go further. So anytime you're given an IP address that belongs to a default class A, you see something like a /8. Please note this when you see it, that the /8 means that the number of bits of ones are 8. That means the network itself there is /8. Then when you see /16, it means that you're dealing with a subnet max that is of class B, which is 16 ones. And when you see /24, it's telling you C, which is 24 ones. So that means that from here, once you give it an IP address, you'll also be given a subnet max, and then you'll be able to tell if it's a class A, B, or a class C. Now, let us quickly go to assigning IP addresses, and then be able to tell the subnet max, and then note if it's a private, public, and then tell the slide notation. So here, I give you an IP address that says 10.0.0.0/8. I give you an IP address that says 172.16.0.0/16, and then 192.168.0.0/24. Now, if I give you an IP address of this nature, what I actually want you to note here is that the subnet max here is 8. That means it's going to be 255.0.0.0. For 16, automatically you know if you bring it back to the settings we had before, it's going to be 255.255.0.0. And then for 24, you're going to have 255.255.255.0. So this is how this came about. So if I go further and give you an IP address that says 192.168.10.0/24. Now, I'm going to ask you this question. What is the first usable IP address here? And what is the last usable IP address? For this kind of IP address, it's a default class C, we all agree. The subnet max is 24, it's /24. That means 255.255.0 because it's actually using a default subnet max. So, and remember, if I ask you what is the number of available IP addresses for the host, you're going to tell me because it's /24. It's 8 1 2 3 4 5 6 7 8, which is 1 2 3 4 5 6 7 8. 1, 2, 3, 4, 5, 6, 7, 8, it is what, 24. And then the other ones are all zeros. Now, if you still recall, here, if I ask you, what is the usable? The first thing that comes to your mind is that you're dealing with the zeros, which is 8 zeros. So it means that 2 to the power of 8 minus 2, which is what? 256 minus 2. So for this given IP network, you know that the available number of usable IP addresses you have is 254. That means it's going to be from 0 to 255. So if you count between 0 to 255, you get 256. And the minus 2 gives you 254. So this is where the 254 comes in. What comes in now is that the first usable is 1, and then your last usable is 254. Is that taken? The first usable is 1, the last usable is 254. Dot 0 is the network address. Dot 255 is what? The broadcast address. So we're going to rewrite this and put it in the right format so that you can understand it more better. So what we're giving is 192.168.10.0/24. So network address is 192.168.10.0. Then first usable. The first usable here is the first number, which is we said is 1 to 254. So the first usable is going to be 192.168.10.1. Then the last usable is going to be 192.168.10.254. And then your broadcast address. For every network, there must be a broadcast address. It's going to be 192.168.10.255. So .10.255, which is the last number, is going to be the broadcast address. Because what we have is 256, and we said it's going to be from 0 to 256, but then as you minus 2, is going to be ending at 254. So the last number is 255. So this is the broadcast address, this is the last usable, this is the first usable, and this is the network address. So for every given address, there's always a network address, first usable, last usable, and broadcast. So you can have other IP addresses in between. Now, we're going to shift away from the default subnet maps to what we call subnetting the subnet. What we call subnetting the subnet. Subnetting the subnet. What we call subnetting the subnet. So we're going to look at subnetting the subnet. Subnetting the subnet. And the reason why this came up is because at a point in time, the IPv4 was being depleted, and there was need for more IP addresses as more and more devices were getting connected. So it had to further go to subnet what they originally had, and then get more addresses. So we're going to look at how to do subnetting. Let's start with Class C, the typical Class C network. So if I give you a 192.168.10.0/24, and I said subnet this IP address. If I say should be subnetted, I'm telling you that based on the number of addresses I'm going to be looking for. So we're going to say, for instance, if this must be done, the first thing here we'll look at is that maybe we need 6 networks. We need 6 networks. If you need 6 networks from this given IP address, how do you work it out? This is private. So let's see if we can make it public. So 1 and 3 is public. So how are we going to do? The first thing you do is that you find the binary equivalent of 6. So you put 6, 2 into 6 is 3, remainder 0, 2 into 3 is 1, 0, remainder 1, remainder 1. So I have 3 bits. So it means that 6, the binary equivalent is 6 bits. So if it is 6 bits, and I'm interested in 6 what? Networks. I'm saying 6 networks. So what do I do? What I'm going to do is I'm going to look at the socket max with the right socket max is 24. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the 4. Then I have 1, 2, 3, 4, 5, 6, 8. Okay, so we have, when we converted this to bits, we got 3 bits. And we're doing networks. Networks are ones. So what happens is that we're going to actually dive into these 0 bits, convert the first 3 bits to ones, because we're looking for networks. So when you're dealing with networks and you're doing subnetting, always note that from your left to right is where you convert the bits of zeros to ones. And when you're dealing with hosts, then you're looking at it from your right to your left. So in this case, we're going to actually convert the first 3 bits of zeros to ones because we're interested in more networks. So we have been told that the binary equivalent of 6 is 3. So we're going to write it as 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then here I'll now convert this first 3 to 1, 2, 3. And then every other one here will be zeros. So you can see what is happening here. So next to do here is that I'm not going to have anything to do with those first 3 octets because they are all filled. So my concentration is on the last octet. Recall that when we're converting from binary to decimal, the last bit here is 128. That's decimal equivalent. The next one is 64. The next one is 32. The next one here is 16. This one is 8, 4, 2, and then 1. So let me write it here. Let me write this one, this last bit here. So 1, 2, 3. 1, 2, 3, 4, 5. So this one we have said is 128. That's my equivalent. This is 64. This is 32. This is 16. This is 8. This is 4. This is 2. This is 1. So this is how you get the decimal equivalent. So if you add 128 plus 64 plus 32, which are the bits of ones here, this is one. This gives you 192 plus 32 gives you 224. So it means that for this particular conversion here, it is 224. But the least bit of ones here is 32. So you look at it, the least bit of ones is 32. But then if you convert all this, you get to 224. So please note this, that what we're going to use to generate our new networks for 6 networks that we've gotten out of this given default subnet max is we're going to use incremental value of 32. So always know that the least one here will be used to generate your network. So since it's 32, this is what we're going to do. We're going to say the first network is going to be 193.168.10.0. The next one will be 192. Let me 193.168.10.0. The next one will be 193.168.10.32. So you can see the next one will be 193.168.10. 32 plus 32 is 64. Followed by 193.168.10.96, and then 193.168.10. If you add the 2, you have 128, and then 193. You can see. .10. If you add 32 to this, you get 160. So this is what we have when we use incremental value of 2. And this is going to be to the range of 193.168.10.31, because if it is at 32, this will end at 31. This is 193.168.10.63, because it's 64. And this will also be in the range of 168.10.95. Then this will be 193.168.10.127, because this actually ends, it starts with 128. And then this is 193.168.10.159. Reason because this is 160. So and then this will now be 193.168.10. But add 32 to this to be 192. This is 192, down here, this is 191. So these are the 6. So if you count is 1, 2, 3, 4, 5, 6. So we have 6 networks. So we have generated 6 networks conveniently from where? From the default subnet mask. Now, each of these networks you're seeing here can actually be assigned to a VLAN, or you can use this for segmentation. So that means systems that are connected within each of these networks stays within its own domain, and obviously cannot connect to the other network until you apply certain routing concept. So that we'll see in the subsequent class. And I hope we actually understand what we've done here. So it means that taking the first one here, we're going to say that the first usable number is 1, the last usable number will be 30. So it's actually from 0 to 131. So the first IP address is 1, the last IP address is 30. The network address is actually +0, which is the first number here. And then the broadcast address of this particular network is 31. And because we have actually subletted it further, if you recall, if you still recall what we did initially, we find the bits of the binary equivalent of 6, which we got 3 bits. And then we converted the first 3 bits of zeros to 1, which gave us this set of strings. So remember, this is what we got. So it means that our new subnet mask for this set of networks is going to be 255, when converted to decimal, 255, then 224 is our new subnet mask. And it means that the entire length of this is going to be 8 plus 8, 16 plus 8, 24 plus this 27. That means we're using /27. So it means that taking the first network as an example, which is 193.168.10.0, which you said is going to end at 31. It's going to be /27. So you can see here that the new networks are actually going to be on /27. So everybody here is going to be on /27. So if you put everybody on /27, of course, that is what we call a classful network, as long as they all have the same subnet mask. I want to believe that we actually have a clear understanding of what I have done here. And then same thing apply for all of this. Please, you need to apply the same /27. And then you also need to work out the first usable and the last usable as the case may be. I'm going to give you an assignment and see if you're able to get it right. So before I do that, I will do this. I will write out the network address. Network address here is 193.168.10.0. The first usable is 193.168.10.1. The last usable is actually 193.168.10.31. Sorry, the 30 in this case, because 31 will be the broadcast. 31 will be the broadcast address. So broadcast address will be 193.168.10.31. So this is the broadcast address. Now, once you get this right, that is how we work this. So if you design a network, for instance, and this is the network address you're using, you can assign one to the computers, you can assign two to any of the devices, and you can also assign one to the router, possibly. It all depends on the design. So we're going to do this in the next class. We're actually going to work out the subnetting, design the new topology, and then carry out the configuration and see how that works out. This is the assignment I'm now. Everybody should do this, and let's see if you're able to get something out. So same thing, I'm going to do what I just did and see if you can be able to produce this back. Here, in this case, we're interested in 10 networks. We're interested in 10 networks. So it means that an ISP, for instance, sold out this IP network to the organization, and you as a network administrator is asked to get 10 networks from this. Possibly you have branches in Kano, you have branches in Kaduna, you have branches in Port Harcourt, where I stay. You have branches in Lagos, you have a branch in Mina, Niger State, a branch in Niger. You have in, help me out, Bauchi. You have in, so we have 1, 2, 3, 4, 5, 6. And then you have in, let's say you have in Sokoto, you have in Enugu, you have in Anambra, you have in where else? Benue State and Kogi. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think that should stop. So it could be out. So we have this 10. So it means that you're going to work out this 10 networks, and this network will be assigned to your branch location in Kano, in Kaduna, in Port Harcourt, in Lagos, in Niger, in Bauchi, in Sokoto, Enugu, Anambra, and Benue from this given public IP network. Reason being that you can actually use the whole of this network in Kano, but because there's some possibilities that all this network in Kano might not be might just be underutilized. And then you have all these branches. And then we are now saying, okay, fine. As a way of trying to conserve, remember, the aim of subnetting is to conserve the IP addresses. So if you're going to conserve IP addresses, then certainly you must see how to get more IP addresses or IP networks from the given IP network. So now you've been asked to do this. Your organization is asking you as a network engineer and said, please generate 10 networks that should be assigned to all this location. So please work at this, and then let's look at it together and see if you're able to get it right. Thank you all for listening, and I believe we find it that interesting. So we'll meet in the next class. Thank you once again, and I look